Hello and welcome to part 11 of how to create a chess game with ReactJS. In this part we are going to implement the moving functionality for the knight. So, which is the knight, is this one. And as you can see, when we move it into a position where we can move, it just falls back. So, in order to fix that, we are going into our referee and where we try to find the good move. So here we try to find the valid move. We check if the piece type is a pawn, and let's see right here, this is the pawn case, and we want to create an else if piece type, or actually type, is equal to piece type dot knight. So let's just console log knight for now, save it up, open up the console, and let's see what happens if we move a knight. Then we get the console knight. Nice. So if we move a bishop, we don't get anything, the king neither, and those other pieces nothing as well. Only when we move the knight we get this console log, so that's good because we want to use we want to create the functionality for the knight right now. So let's see. We did for the pawn was we tried to look for the special row in the pawn direction, and we've implemented the moving logic based on that. For the knight it's going to be a little bit different. We're going to write moving logic for the knight, and right here we are going to create an if statement because, well, let's first write it in our comments. We can move into 8 different positions with the knight. So if, for example, the knight is, let's say, well, we can actually change that in our constants right here. Let's say that the enemy knight is in the center of the game, so x5 and y5, maybe 3, then he should be right here. Yeah. So this knight can now move to 4 different spaces: to the upper left, to the upper right, here to the right, here to the right, here to the bottom, here to the bottom, and here to the left, and here to the left. So the way the knight moves is it moves 1 square vertical or horizontal, and then 1 square diagonal. So horizontal, diagonal, horizontal, diagonal, and then in all directions. So it has 8 different tiles where it can go. So let's go into our referee, and right here we are going to create 8 different moving patterns. And the first one, let's start with this one, which is up and up left. So we say if, and then we say the desired position dot x. Let's see, the desired position dot x is 1 to the left from the original position. So we say desired position dot x minus initial position dot x is equal to -1 because we move 1 to the left. And then let's see, the y position should be 2 to the top. So we have the desired y position is, let's see, 0, 1, 2, 3, 4, 5, and our initial y position is 3. So we say 5 minus 3, which is equal to 2, right? Yeah. So we have this, and then we have desired position dot y minus initial position dot y is equal to 2. So this is for the upper left, and right here, let's just look if we can log anything. Upper left knight movement, like so. And let's see, if we refresh the page, we move our knight into this position, nothing would happen. Here as well. But what if we move it to here? As you see, we now get the upper left knight movement. So we actually have already one of the 8 positions. So the next position is the same y value, but a positive x value. So we say desired position x minus initial position dot x equal to 1, and desired position dot y minus initial position dot y equal to 2. Then we have the upper right movement. So right here, upper right knight movement, like so. Let's save it up, refresh the page. If you move to here, we should see upper right, and here upper left. Nice, that's working correctly. So actually, instead of having two if statements right here, with both having this, we can actually say if and then this. If we are in the top row, because we actually have 4 rows. We have a top row, a right row, a bottom row, and a left row. So actually maybe we should call them lines or something. Top line, right line, bottom line, and left line. We first do the top line. So this is the top line. And then for the top line we check if it is moving to the left or to the right. So we say if this, then it is left. And if this, okay, this one. Good. We can remove this if. We move to the right. So we say console log upper right night movement. And we can remove this. And now we have destructed it, or well, we have changed it a little bit. We are now handling one block at a time. So this is the top line. Let's go with the right line. Top right line, like so. And then we say, okay, so the basic thing for the right line is that the x value is always, let's see, 2, I think. So desired x is 0, 1, 2, 3, 4, 5. Initial x is 3, 5 minus 3 is 2. Yeah, so if desired position.x minus initial position.x equal to 2, then we are in the right line. And then we want to check the top and the bottom position for the night. So if desired position.y minus initial position.y equal to -1, I think this should be, let's see, -1. Yeah, that's the bottom one. So console log right bottom night movement, and let's change this to top left. So top is the line and right is the line as well. And then we are also going to say if it is equal to +1, we have right top night movement. Save it up and refresh the page. Top left, top right, right top, and right bottom. Yeah, nice. Okay, so we also have the right line. Let's go for the left line right now, or the bottom, actually, the bottom line. And for the bottom line we can actually use this. Let's see, like so. And actually we can better copy over everything from here. So the only difference is that this is -2 and this will be bottom and bottom. Since for the bottom one we also want to check if it is moving to the left or to the right. But the only difference is that the value is -2 instead of 2. Let's try it out. Bottom right, bottom left, nice. And then finally the left line. And as you might notice, are already creating duplicate code, but it's good that you notice, good job, but we are going to change that. So we are first going to implement the left line, and for the left line we are going to look at -2 and to say left top and left bottom. Let's save it up, refresh the page, and if we look at here, we see that we have the top left, top right, right top, right bottom, bottom right, bottom left, left bottom, and left top. Yeah, okay. So now that you have all the positions for the night covered, we can start by optimizing the code a little bit, because as you can see, the top line and the bottom line are actually exactly the same, with the only difference being this is +2 and this is -2. So let's create a for loop. Let I equals 0, I smaller than 2, I++. Let's console.log I. So let's see what we get. We get 0, 1. So how about we change this a little bit and we say that it starts with -1. See how that looks. But then we get 3 values and we actually only want 1 value. So what we can do is we can, instead of saying I++, I plus is 2. So we add 2 each iteration. And then we should get 1 and -1. Nice. So what we can do then is we can just copy over this top line. We can paste it in right here, and we can say 2 times I. And what happens if we remove the bottom line? We will still get the console logs when we move to the bottom. So let's change this to top or bottom, and here as well, top or bottom. Let's save it up, refresh the page, top bottom, top bottom, top bottom, and top bottom. Nice. So we've actually reduced this by just using a simple for loop and by altering the initial state or the initial value and the value that's being added every iteration. We have now created a nice -1 and 1 loop for our night. So we can remove top line from here, and we can actually do the same with the right and the left line. Let's just copy over this. Let's say 2 times I. We can also remove this, and right here we say right or left, and here as well, right or left. Save it up, refresh the page, and if we move our night to the right or left, and if we move it to the left, we also see right or left. Nice. So now we've got one if statement for both sides. And just as we made a variable for the top and the bottom and the left and the right, we can also create a variable for the left and the right side of the top and the bottom, and the top and the bottom inside of the left and the right, if that makes any sense. We're going to say if let, or I mean for let j is -1, j is smaller than 2, j plus is 2, and we're going to wrap this inside of there. And then right here, we can remove this like so, yeah. And then we say, instead of saying -1, we say j. And here the same. Instead of saying 1, we say j. And this should say top, bottom, left, right. This should be right, left, top, bottom. Let's check it out. We've only got 2 blocks of code instead of the initial. How many do we have? 8, I think. Did we? 1, 2, 3, 4. I think 8. So let's see. Top, bottom, left, right, right, top, bottom, left, right, top, bottom, left, right, top, bottom, left, right, right, left, right, left, right, left, right, left, and right, left, right, left. Nice. Yeah, and when we move to here, we only get denied because it's not a valid. It's not a valid tile. So we have now created 2 different code blocks. Let's add some comments to there, so we still know what's going on after a couple of episodes. So here we say top side movement, and here we have bottom, or actually this should be top and bottom side movement, and here we have right and left movement. Good. So we actually already implemented 8 different move patterns. Moving logic for the night can be gone because we have specified this right here. We console.log night. We don't need to do that anymore. What we do want to do is we want to check, see if there is a tile or if there is a piece on the tile. So I really don't like how this wrapping is happening, but we just got to deal with it right now. It's the only reason is because of the positions which we did at last episode, but yeah, we just got to deal with it. So let's see. We should have the valid move. Yeah, the valid move function right here. Here we check if, see, this is a special move. We don't want that. We have the normal move. Yeah. So the normal move is right here, and there we check if the tile is occupied, and if it is not occupied, then we return true. And actually we can even write this short by saying return this. Well, let's just leave it like that for now. Maybe it has some reasoning behind it, even though I wrote it myself. So let's see, this is where it gets interesting. Here we have our attack logic. So here we check if the tile is occupied by an opponent, then we want to return true. Or if the tile is not occupied. Okay, so well, the difference between the pawn and the horse is the pawn can move forward, but it can only attack diagonally. That's why we have two separate statements. But for the horse, we move random, or well, in a circle or a square, and we attack on the same positions. So if we move to here and there is no piece, we can move. But if there is a piece, like now, we take it. So that's how the horse works. It doesn't have, or the knight works. It doesn't have a different attack pattern than the movement pattern. So let's check it out. We're first going to check if the desired position doesn't contain a piece. So we say if, where did we, oh, not there. So we say right here, if this dot tile is occupied. So if nobody is standing on the tile, and then we say desired position at X, desired position at Y, and then the state, port state, yeah. If it is not occupied, then we actually want to, and it's already wrapping like this. I really don't like this. How can we fix this? Well, we could fix this by saying that we want to pass in a position in the tile is occupied. Can we just do that? Yeah, because then we can use the position function right here. Oh my god, that we didn't do that before. Amazing. So right here we pass in a desired position and a board state. Right here we expect a position which is a position. So, and then we check if the same position, and then we check p dot position and the position which we get from there. So now that we have that, it even wraps itself in one line. That's how short it is. Now that we have that, we need to fix some errors right here, I think, because we check for the desired position that X and Y. We can just remove that. Here we need to do something different because we want to subtract something else. So the X will be the desired position at X, and the Y will be desired position at Y minus pawn direction. So this one is a little bit longer, but it's okay, it's doable. If the rest is better, it's fine by me. Here we have a normal desired position, so let's go, and that's it already, I think. So what we can do right now is what we have already done. We are just checking if the tile is occupied, and if it is not occupied, or if there is a opponent on it. That one is also with X and Y. I'm going to change that one as well. So let's see, Y, let's change that to position. Then we've got to do the same right here. Same position, p dot position. We can remove this, like so. Yeah. Auto formatted, and here we have position. See, we can use this from 3 to 1, or from 2 to 1. That's improvement, right? And then right here we have, is this it? Oh no, we need to pass in a team, right? Yeah, a board state and then a team. So we need to know the team of the pawn, so that should be team, like so. Okay, so we check if the tile is not occupied, or if it is occupied by an opponent. Then we execute this. So I'm going to do one little trick right here, and that is to create a wrapper function, and the wrapper function will be tile is empty or occupied by opponent. Okay, maybe this is going a little bit too far. I don't know. How long should function names be? Tile is empty or occupied by opponent. Well, if it is too long, just tell me, guys. Just tell me to change it. But for now, I'm just going to keep it like so. And we're going to give it a position. So, a board state, which is type piece array. And then a team type. So, and then inside of here, we return tile is occupied. So if it is not occupied, it should be empty. Pass in the position in the board state, or tile is occupied by opponent, like so. And then we pass in the position board state and team. So that's what we return. And let's see. Now we can use this function, tile is empty or occupied by opponent, inside of here. Instead of writing those two, we can just remove this and place this, and it didn't make it better. But well, now you know, you can just wrap two functions into one, and you get absolutely a little bit of profit, I think, if it is even worthy of being called profit. But yeah, we have this if statement, and inside of here we know that we can move on it or we can smash the opponent, so we return true, because that is what we return when we can move to a tile or attack a tile. So if everything is right, we can now attack top bottom, yeah, or move top bottom. Let's try it out. Yeah, our horse is moving. See? Yeah, okay, nice. So now we can move to there and not to here, I think. No, because that's left right. So let's see if we can also take pieces. We can also take pieces. Okay, this is going better than expected. Can we also take the opponent's horse? See? Well, I think this is a little bit comfortable. Ah, no, we cannot, because we cannot go left right. Okay, so I think we should first implement the left right logic before we can hit enemy horses. So we're actually just going to do the same. We're just going to grab this function. I'm just going to remove the logs right here and apply this function right here. Save it up, refresh the page, and let's see. If we move this horse to here, here, yeah, nice, great. Okay, so as you can see, we can just move our horse around. We can even take horses, which is also amazing. And now is a great time to test out the ampersand move, because if we put our pawn right here, we can take it. But what if, see, right now this horse can take this tile, move our pawn right here. Yeah, we can move our horse right there, but it won't take the pawn, because the ampersand move can only be executed by another pawn. So that's also working. I think it's looking really cool. I'm really happy with how it turned out. It's a lot easier for the horse than I thought it would be. I think the biggest challenge will be for the bishop and the queen and the rook, because then we need to apply some ray vision, because if you move a bishop from here to here, we need to check if there is anything in between those tiles. For the rook the same. So once we've got it down for the bishop, we can just apply the same for the rook, and for the queen as well. You can also move in a line diagonally and horizontally and vertically. But for the horse it's more simple. It can just drop itself, drop it like it's hot on the tile. That's why the horse is a little bit more easy to program. And finally we have the king, and the king is actually also not that difficult. He can just move one tile vertical, horizontal, or diagonal. But there is one thing that we still need to work on, and it is checking and checkmating. And we need to check if a move is legal, because, for example, if we have our, let's see, can I move my horse? Yeah. If we have our horse right here, yeah, no, I cannot take my own pieces. If I move my horse right here and then move it, so we have this situation, and actually want to fill in this gap. But anyways, right now the king is being attacked, so moving the horse to here should not be allowed, because you cannot move while you are under check. So the horse should take, or the queen should take, or the bishop should take, or the king should take, or the king should move away. But any of those moves is correct, but not just doing anything else. So that's still something that we need to work on. I hope you enjoy it until now. I really do. When I was beginning, I thought it was going to be okay, but now that I'm programming it, it's a little bit more of a challenge. So I'm always in for a challenge, so that's good. So with this, I want to end the episode right here. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!